What the hell happened to this Pioneer SX1050? Welcome to Lancaster Hi-Fi. I'm Stephen Lancaster. I'm going to talk to you today about repairing a Pioneer SX1050. In the end, I'm going to give the end away. These two half-ohm resistors burned up and failed. Failed not completely open. One of them failed completely open. The other failed such that it had, tens of K resistance or something like that. Just looking at them, you can't tell that they burned up. You look closely, you can see there's a bit of discoloration there. Maybe smoke actually did come out of these. It took me forever to figure out that it was these. I want to show the process, my however flawed thinking process that finally led me to check these resistors and figure out that these were the failed components that were responsible for the problems I was having. And I want to wrap up how the various symptoms that I was getting could have been indicative of these having failed. I'm going to show you the footage, and you can scream at me along with me while I'm editing it, going, it's the two resistors, it's the friggin' bias resistors, figure it out, Pioneer SX1050, tried it with the dim bulb tester, just sort of smelled, plastic burny type smells, but no smoke. Then plugged it in regular, and I got a bit of smoke here. Can't tell whether it was coming off of that variable resistor, which I think what that is right there, or something maybe just next to it, maybe that transistor. It was coming right up here, and there was a bit sort of along here as well, but mainly straight up here. And then noticed smoke from here, where we see the charring under those wraps. And those are resistors, and that is, I believe, the protection board. So I turned it on, and I never heard the relay go unless it came on instantly. Let's just see again. Yeah, so the relay's not clicking. And if there's just ridiculous voltage across a couple of resistors here, then that would tend to perhaps explain why the relay is not. And so far, what have I checked? I did check the capacitance on these two big caps. These are 22,000 each, and they measured 18, although that's kind of at the limit of what my LCR meter can measure. And my recollection is the initial report was of smoke back here, back in this area. Whether that was coming off of the amp, or I think this is the main power supply board. And so I did see smoke, and it was coming definitely off of the power amp right here, and maybe even a little bit over here as well. It's not clear to me that that's not just dust and lint burning on hot transistors. This, however, is not just that for sure. So there we go. Found a couple of VANE 2 charred resistors here. Turning it on and leaving it on for a little while may have made those charred looking where they weren't charred before. They do look like fusible resistors, so kind of meant to burn out. The resistors in question are R48 and R46 on the power amplifier board. Those are both 100 ohms. I need to check the schematic and see what they do. Sources of smoke, R48, R46. These are 100 ohm resistors just upstream of the driver transistors. There's like 8 power transistors, and those are over here. Looks like there's 8 drivers as well. And I had some potential smoke from this variable resistor here, this 470 ohm. Alright, so what do we got? Way too much current going through these, so over voltage. Now this is only supposed to be at 1.8 and minus 1.8. We got 60 volts here, and then minus 60 down here. Okay, so the other cooked resistors, or cooking, are R3 and R4. R3 looks a little more cooked than R4, at least according to the charring on the jacket. And those resistors are on the protection board, and those terminals are connected via 22 ohm resistors to the emitters of the power transistors. And I guess that would indicate way over voltage here and here. Duh. Power amp has these handy plugs that connect it to the power transistors there. So I've unplugged them for the smoky channel. Check this out, flip the switch, we are on the dim bulb tester. And the relay engages. So that would seem to be where the problem is. Once I've disconnected those transistors, then I'm not getting the bad voltages over on the protection board anymore, but still getting quite screwy voltages on the terminals of both of these resistors, all negative, so these more negative, but these also quite far negative, like minus 35, 36, minus 33, 32, something like that over here. Now, I think I would tend to implicate Q10, and essentially a shorted Q10, although I measured it, and tried to measure the resistance across here, and that was like 2 mega ohms. Obviously it's getting way too negative a voltage here. It's connected by these diodes to here. And so that would say, we've got this large negative voltage here, which is putting a similar but not quite as negative voltage here. In order to do any work on this power amp board, I've got to take it out of here, which means I've got to disconnect all of these, which is a pain. It does save those connections from getting stressed. So here's the board out. I replaced the 2 resistors that got charred. And you can see the other 2. And I replaced these 10 microfarad capacitors in the middle there because they both tested over spec, which means they're probably leaky. I believe the originals were 16 volt, these are 63 volt, which is just great. I tested both of those sets of 2, and those look good, so I'm going to leave those alone. Tantalum capacitors there, I'm going to leave those alone. Everything else I think should be fine. The transistors on this channel tested bad. And I can't tell if it's all 4 of them or 2 of them, but they were all kind of screwy readings. These all tested good. However, if you're going to replace all the power transistors on one channel, probably should go ahead and replace those on the other channel as well, so we'll do that. But I need to order those. There's like $8 a piece. Found the replacement parts listing on Audio Karma. Awfully handy. Somebody had restored one of these and replaced like everything. Because finding an exact replacement for these is kind of tricky, particularly trying to find some with good enough gain. Given that somebody else got good results with the ones I'm using, which are with the MJ 21193 and 21194 Gs, it should be fine. Okay, notes on disassembly. I need to get the big heatsink out, because that's, of course, what the power transistors are attached to, and I need to replace the power transistors. You know, I've already unplugged these from the driver board. It looks like the driver board is mainly attached to a piece of metal framing here that is attached in turn to the heatsink. There are also these two transistors, or whatever they are, that are also attached to the heatsink, as well as the driver board. And so in order to free the heatsink from the rest of it, I'll need to unscrew these. I'll need to unscrew the frame that's holding the driver board at these 4 points. And then, once the driver board and the heatsink are separated, then 2 screws down there and 2 screws up here should free the heatsink to be removed. I've replaced all the power transistors, and after that I still had a minus 9 volts at the right channel output, which was the problem channel. Before I even get to that, I need to address the fact that the protection circuit didn't kick in and prevent that minus 9 volts from appearing at the output. If I go to the protection circuit, I do have these resistors that have produced smoke. I lift up the board and I note there are some untrimmed leads, and those correspond to the smoking resistors. And I look inside there, and at least one of those has 2 resistors in parallel, podged together. It's not necessarily a bad thing, I'm just saying. Okay, I'll just say it. It's a bit of a sloppy job there, not trimming those resistors, not cleaning up the solder, although I can forgive that actually, more than not trimming the resistor leads. Given that these have smoked, it would seem that the first order of business is to address those and see whether they're any good anymore, and still in spec and all that. So this is the DC voltage detection circuit, and you can see that it's a differential amplifier. Q2 is connected to both the left and right channels, but through a blocking capacitor C2, and Q3 also connected to both channels, but not through a blocking capacitor. And so if there is DC on either channel, it should register as a difference between what's in the Q2 and Q3, because this will necessarily be at 0 volts DC, whereas this will be the actual voltage of the output. That should induce different currents through these 2 transistors, which will then drive the relay circuit to engage and turn off the output. We might suppose that one of these transistors isn't doing its job. In particular, I would suspect Q3, although these should, if I'm going to replace one of these, I should probably replace both of them, because they are part of a differential amplifier and should be the same transistor. Now when I get down to the board diagram, or the board level diagram, things look a bit different, because now I've got 2 of these sets of inputs. The transistors in the differential amplifier are Q3 and Q4. Okay, I've got back-to-back C3, C4, so that's our combination, effectively bipolar blocking capacitor. Q3 and Q4 up here at the top. So that would be these 2 here. Here's our back-to-back 470 microfarad blocking capacitors. Any electrolytic is going to be suspect, of course. Because if those are leaking DC, then that would defeat their purpose and the circuit wouldn't function correctly. So maybe I better check those first. Alright, I've got an indication that those may be leaking. I did DC resistance from positive of one and positive to the other. They're on the diagram, their negative terminals are connected. And I got 4.5K. Now I will want to check them out of circuit as well, because trying to check stuff like that in circuit can be pretty unreliable. Out of circuit, I mean they are both in spec, both reading DC resistance in mega ohms and capacitance value well within spec. It's not unusual that they would be different in and out of circuit. Alright, so that just brings my focus back to the original suspect, which were the transistors there. That's Q4, ECB, gain 212, UF 687 millivolts, just perfectly fine. And I suppose my next suspects would be these transistors at the inputs to the protection circuit. And alright, channel 1 looks just peachy. So now I'm in this uncomfortable sort of, well, what the fuck? I don't know what's wrong with it. Is it even worth trying to track down at this point before I track down the other problem? Alright. Checking voltages. Boy, oh boy. Q18, where's Q18? Its base is sitting at 44 volts. It's separated by an 18K resistor from this 60 volt supply, but running on the dim bulb tester, this is reading 45 volts. So I've got 45 volts here, 44 volts here. I'm thinking maybe this resistor is shorted, just a guess. R50, not shorted, reading 17.8K. Okay, so if there is nothing wrong with this resistor, and it's supposed to have positive 60 volts, in this case positive 45 on one side, and minus 1.2 on the other, it should be passing quite a bit of current. Now where is that current supposed to go? Well, not supposed to go into the base of the next transistor. Base currents are finite but small. So that current should be going through Q14. So if there's like no current going through Q14, then that voltage would be sitting way high. That makes sense. Now the question then is whether Q14 is bad or whether it just has bad voltages on it. So let's see. Q14 has a collector sitting at the negative supply. Its base should be minus 1.8. Its collector, its emitter should be at minus 1.2. So it should be conducting. As long as the voltage here is somewhat negative with respect to this, which it is, or should be, then it should be conducting. So I guess then the question is, well, what's the voltage here? And what's determining that voltage? Well, it's supposed to be at minus 1.8. Got some diodes between it and the minus 62. Basically, I don't think there should be any current going there. Should be basically just determined by the diode drop here. Alright, here's Q14, and it has conveniently voltages noted on here. Should have minus 60, in this case like minus 45 on the collector, minus 1.2 on the emitter, which we know is not the case, and minus 1.8 on the base. That's right here. So I've been putting off taking this out. Positive 16 volts here, minus 45 or so at the collector, and like 44 volts at the emitter. 44 volts here, 16 volts here, should be conducting like crazy. Gotta be a bad transistor, doesn't it? It's always gotta fucking figure out how to take the power amp out of here. It's huge, look at this thing. What I did before was unsolder all those connections down there and and then disconnect these, obviously disconnect these, and then obviously undo the screws here, 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 and then it just comes out. So as I said in my previous note video, it's a pain, but it's unfortunate because I can't, once I pull the board out, of course I can't test anything. I gotta be pretty damn sure that that transistor is the fault, or just replacing everything, which you could. His angle's trying to get the desoldering tool in there. I think the first move is then to drop or pull the heatsink, get it out of the way so I can get the tool there. Okay, with the heatsink and that metal thing removed, I may not need to undo all of those connections. And of course it tests fine. Fine. It tests fine. So maybe I need to back up in the chain. Maybe I need to back up to Q10. It's supposed to have 3 volts here. Clearly doesn't. Only a 100 ohm resistor separating the two. I think that is one of the ones that was burned out that I replaced. Knock me over with a feather. Q10 is fine. 126.96. Fine. This one checks fine. This one checks fine. The output ones are brand new. Well, here's a fucking issue. These leads aren't soldered. I think I probably did take those out to check them. Yeah, we got a bunch of leads not soldered. Here, here, and here. Did I do that? I don't know. Probably. Yeah, appears to be working fine now. Yeah, that's pretty amazing. Setting the DC balance, and that's the left channel. Alright, so all the problems that I had after putting in the power transistors were simply due to my own boneheaded not resoldering everything attached to this heatsink right here. That means all of today's labor up to this point has been free of charge. I'm trying to figure out the problem with this protection circuit. Specifically, the relay keeps going in and out. Right now, it's where it should be. If we watch it long enough, it'll probably click back out and then back in, which is at least an improvement over what it was doing. So what have I done? I've replaced this capacitor, which is in part responsible for holding the voltage on the base of this transistor. I've replaced this transistor and this transistor. This was a 1384, this one here, and this was a 945. Replaced it with an 1815. This is a 1616, which is not necessarily perfect replacement for the 1384 because it can only handle an amp as opposed to 1.5 amps of the 1384. But I think when this thing is on, it should only be drawing 18 milliamps, so we should be good. I replaced the capacitor because I thought, well, so I monitored the, oh, there we go, see that? Now it's doing the trick. So it seems like almost okay for a while, and then it gets into this mode where it's just doing what it was doing there. Looking at the voltage on the base of this transistor, it fluctuates. It should be steady at 9.2 or 9.5 or 9.7, whatever it is. But it's fluctuating when it goes in and out like that. It'll drop down to, 4 to 7 volts for I don't know why. I don't know what reason. Because it's not really supposed to. This voltage is not supposed to change. Rather, this one is reverse biased and its base voltage is supposed to change. And when it turns on, it'll supposedly turn off this one. Now I haven't, that could be what's happening, but I don't think the voltage here is supposed to change when this turns on, but I could be wrong. You know, for all I know, it's functioning well, and there's something going on in the amp. So that's where I am at with this. I spent a couple hours on this. Again, this is better than it was. But better isn't right still. It only happens when there's a load on it. If you connect it, if you turn it on without a load, that is without speakers or a dummy load connected, then it won't do this. I got the idea basically by breaking one of these diodes. Okay, let's back up here to the protection circuit. So the protection circuit works by, if any one of these diodes starts conducting, then that'll tweak the voltage on the base here, which will tweak this. This will start conducting. This voltage will drop. It'll turn off this one and therefore turn off the relay. And I was trying to check these diodes and managed to break one of them. They're glass. There we go. Right there. And then I got the idea, you know what? If none of those diodes are connected, then the protection circuit shouldn't go into protection. If I disconnect these diodes one by one, then I can A, find out if the protection circuit is acting as it should, which mode of protection is triggering it. And if it still does it with all the diodes disconnected, then it must be over here. I've actually already replaced both of these transistors thinking they might have been the problem. But no. And I didn't get any results until I disconnected D8. Then without D8, it didn't go into protection. And then I'm looking at, okay, well, D8's fed by these comparators, trying to look at DC on the outputs. And checked each one of these lines. Finally, with it on the number 5, most of the time, or at least some of the time, it's fine, and then it starts going haywire. So that's our problem. Now, where is that coming from? That's coming from these sense resistors connected to the emitters of these two power transistors on the right channel. I replaced those. Those should be fine. Should be. But that was where there was a problem initially. So now I need to figure out, okay, well, what exactly is causing that particular problem? Is it a problem with those transistors, which it shouldn't be? They're brand new. Well, I seemed to trace the problem back to at least here. And since that's the easier transistor to change, that's the one I've changed. Substituted in a KSA 992 for that. Yeah, that was a 2SA 858. And I could replace this one, but I don't have any thermal paste, and that one needs thermal paste. And I'm looking at that same terminal on the protection board, the one that was giving me DC voltage on and off before, and now it's pretty stable, very, very small voltage, which is a very, very good sign. Knock wood. I might have fixed it. I spoke too soon. I couldn't catch it on video, but it went a little haywire there for a minute. Seems like before I didn't have any trouble capturing it on video. I was doing it pretty damn often. More transistors. There we go. Again, so far so good. It's drifted around a little bit, but only, plus or minus a couple of millivolts. So this time I replaced these two with KSC 1845s. Now when it drifts to negative voltage, it's just going a few millivolts. I don't know why it does that. Seems to be something it wants to do. Oh. Yeah, I was beginning to think I might have gotten it, but it just did it a couple times where it real quick went down to, minus a volt. It's kind of odd that it's just not doing it nearly as much as it was before. It's hard to know whether it's even a big deal, because before it was just going berserk. It would reach times where the relay just wouldn't engage for more than a half a second or less. Now it looks like it would be nice most of the time, and then you get these occasional little cutouts. I mean, it seems like replacing the transistors that I've replaced has done something, but maybe not completely fixed the issue. And I guess now I just don't know whether... See, there we go. Well, this is super frustrating. Recap the problem that I was having. Protection circuit wouldn't stay engaged. I seemed to track the problem to pin 5 here. When I removed diode 8, which connects this basically voltage comparator to the protection circuit over here, remove diode 8, the relay stays engaged because it's not getting wonky signals. When that diode's removed, then the load stays on the speakers and I can measure the source of the wonky signals from one of these pins. And it's been pin 5 here. Pin 4 is okay, pin 7, pin 6, they seem fine. And so I traced where pin 5 comes from, and pin 5 goes to the PNP side of the right channel down here. It goes to pin 19 specifically, which is connected through 22 ohm resistors to the emitters of the output transistors. Well, I've replaced all the output transistors. I went in and I started trying to trace back the source of the issue. I ended up replacing first, I think, this transistor. Then I'm pretty sure I replaced both of these transistors. And then finally I replaced this one. The reason that I had to delay replacing that was because I needed thermal paste in order to do it. That's a T220. Last night after I replaced that, everything seemed fine. I don't know, maybe the dummy load wasn't well connected. I don't know. Because when the dummy load's not connected, when the circuit's unloaded, everything's fine. It's only when it's loaded that this business down here goes wonky. Let's try to reason this out. So again, it's pin 19. That's connected through these 22 ohm resistors to both of the emitters of the output transistors. And those are connected through half ohm resistors to that point. It's supposed to be 0. So that's going to the base of the other side of the input differential pair. And that's how I do the feedback. The feedback goes to this second in the transistors, and the input comes in here, and you got your differential amplifier. There's a couple of ways you can get anomalous voltage here and here. If this is at 0, and this is not, and then therefore these are not, and the collector is at minus 62 volts. So if these are anomalously negative voltages here, and this is 0, then that would indicate you've got way too much current going through here. Where's that current coming from? It's got to be coming, that means way too much current here. And then why is it getting told to put too much current through? So this is also connected through this business here. So this is the Zobel network right here to 16, which I think must be ground. 17 is actually the pin with which I check the DC bias. So that's supposed to be 0. And the bias is set without a load. It specifically says disconnect the speakers to set the DC bias to 0. So I can check this with the load. I mean, I already checked it without the load, and it's fine. But it's always fine without the load. It's with the load that the problems come in. So that point is supposed to be at 0, but it's not ground. But if I can find that that voltage is fluctuating, then maybe that would help figure out what's going on. All right, so that is just fine. That pin 17, again, pin 17 is right here, and that's the one that's used to check the DC bias. You know, note that it's also connected in the same way to this pin 15 that goes to the pin 4 on the protection board. So as long as, okay, so anomalous voltage here does not seem to be corresponding to anomalous voltage here, and by extension here. So anomalous voltage here is just at these, and there's pin 19. Yeah, we're getting ridiculous voltages. That should be 0. But it's just fluctuating all over the place. Now if I turn off the speakers through this switch right here, presto, it's near 0 again. Turn on the speakers. Well, maybe it'll be fine for a little bit, and then not so much. I don't know. Of course, this switch could be bad. Let's try that again. And I think that switch may be bad. If anything, this is worse than it was before, but again, when I checked things last night, it seemed to be fine for a long time. It just sat at like 4 millivolts. Now look at it. But I don't know. Things are screwy all over. Okay. Break this down. Checking other voltages. Whereas, you know, these emitters and these emitters should be at 0. Finding a problem that these are not. Whereas these are sitting at 0, these are sitting at like -1 volt even, but fluctuating. Now, next thing to check is then the base, both sides, but I hadn't really thought to check the base up here. The base should be at about -0.6 volts. And it's got this 10 ohm resistor between that, between the emitter of the driver and the base here. Same over here. This one should be at 0.6 volts. But they're not. Okay, so I'm at the top. Let me see which pins we're needing to check. We're talking pins connected to the bases. So 24 is on the NPNs and 28 is on the PNPs. Again, the PNPs should be at -0.6 and the NPNs be at +0.6. And those are respectively, so here's 24s right there. That's the voltage, it's negative. That's the PNPs, similarly negative, but somewhat erratic. But the other one's erratic as well. And on the NPNs, negative voltage, and similar negative voltage. So, no, they're not tied together. How are they related? The 0.6 is in part biased through this 4.7K resistor to the negative voltage. The negative power supply would be around -60 volts. And this -0.6 biased also through a 4.7K to this, which is, that's at +60 volts. That's how those are biased. Again, they're both not what they're supposed to be. Especially the NPN side is not what it's supposed to be. What the hell is going on here? These sorts of problems are difficult because something goes haywire. I think it was these transistors that went bad. and you start drawing crazy current through other parts of the amp circuit, and some things fail. You know, we've got various resistors rated at 2 watts, and maybe they were choking on more than that, and so maybe they're bad. Okay, so again, let's back up here. If this is too low and it's connected to the negative power supply, so it should be a bit positive. So it should be like, you know, 62 volts plus 0.6 volts above that power supply, right? Since it's not as far above it, it's slightly negative, there is less current through this resistor than there should be. On the other hand, this one is more negative than it should be, then there is more current flowing through this than there should be. Or the resistors have the wrong value, and I'm pretty sure I've checked the values on these, and they're both right on 4.7K. It's good to just check the good channel. So here's the base of the power PNPs on the left channel. 1029, base of the PNPs on the left channel. And it's sitting rock solid at minus 0.6 volts. And then we can look at the base for the NPNs, and it's at plus 0.6 volts. So the left channel is peachy. Right channel, everything's K-wire. Not sure what to do other than just start replacing more transistors. I mean, I'm kind of at my wit's end other than just start replacing parts. Hope something works. I mean, it's a pain in the ass. You know, ideally you'd want to replace one component at a time, see if that fixes it. But every time I replace a component on this board, I have to take out everything. I have to disassemble all that, take out the heatsink, and then I can get at the back of the board there. You know, you get to where it's like, well, do I bother with this business of checking after replacing each component? Instead, maybe just replace a bunch of components at the same time. Overall, I've replaced all of the power transistors for this unit. And then in the right channel, I've replaced the PNP driver. You can just tell by how dusty they are or are not. I've replaced 3 other transistors back there. These 2 and this one. Those correspond to these 3 transistors. I thought the problem was entirely on the negative going side, or the side with the PNPs, but it seems to not be just that. So my thought now is to start replacing other transistors, and in the meantime, check other components. I mean, diodes? I don't know, maybe some diodes have gone nuts. Doesn't seem likely. Diodes are pretty freaking robust, but I mean, solid state transistors are pretty fucking robust too, so what the hell. So, after replacing all of the transistors in the right channel, all the way back to here, I finally checked some resistors, and these 2 have failed. One of them's reading 77K, and the other's reading basically open. And these are these beefy fuckers. These things. Are you fucking serious? But, check it out. Fucking charge. Gotta come up with half ohm resistors. Well, I've got no half ohm resistors handy, so I'm gonna have to order some new ones. They're like $1 a piece, as long as you get 10. This receiver has been a chore, but just replace those 2 green resistors there. They were like the white ones, but now they're green, and now it works. The secrets are all the same. I replaced this bulb, not with a brand new one, because all the others are not brand new, and I replaced it with one of the good ones off of my Realistic STA 2000, and I plan to replace all of those. Anyway, now this has all working incandescent. Some of the veneer at the back was peeling up, and I didn't want to risk it coming off, so I glued it and clamped it with my veneer clamp. I will still be on my feet. New filter capacitors. These things are friggin' ginormous. I don't think I've ever gotten a capacitor this large before. You know, I did get them, you know, trying to match that diameter. I didn't expect it to actually be that easy. And I think what it is that these are very long lifetime capacitors. Can't remember whether it's like 9,000 hours at 105C or 85C, I can't remember. But they were near the upper end of lifetime. Of course, with the lugs, I just hope the screws that are already on the bottom there fit those, because there's no screws with these capacitors. I just deoxited all these push button switches. I had previously done all the pots and toggle switches, but at that time I had forgotten about the push buttons, so I just did those. That's why the thing is on its rear end like it is. The way to do it is you go in with the deoxit and you squirt a little bit on the stem of the switch and it seeps down because it's on its butt, and then you work the switches. Now, here we have the bottoms of the old filter capacitors. Let me see, there are screws. So I'm hoping that those screws fit the new capacitors. If they don't, I'll have to figure something out. It looks like these may be changeable without actually even doing any soldering. So we've got one big piece of metal holding both of these on. No, not one big piece. Two pieces separated there, down there, and held on by screws up here and here and there. And then there's this sort of holding shit together in the middle there. I want to make sure I get the orientation right, because there's no marking on the sides of this for what's negative and positive. It says negative black. And so the negatives are on the top or on the right side as you're facing the front, top as they are now. So of course the things that the bolts have to go through are now too small since I'm using bigger bolts with these bigger lugs. Note to self, you can't drill out these things, not with just trying to hold them with needle nose pliers. So, gotta dig through some connectors and make new connections there. Doesn't look like a lot of slack, and I don't think I'm gonna be able to pull those wires free. I'm gonna probably have to cut. So I was able to cut off the old connectors without cutting the old wire ends, and I got them good and crimped, tugged on them a bit to make sure that's good and solid cold weld, and screwed them on good and tight. It's a little rinky-dink what with the assorted screws, but you know, in the interest of getting it done, that's what we got, and it works. It will work, knock wood. I want to wrap up how the various symptoms that I was getting could have been indicative of these having failed. Now, I don't know that these had failed at the time that I got the unit. Probably. But I don't know that for sure. I know that it had already released some of the magic smoke before I got a hold of it. But I also know that I turned it on and let the smoke out for a bit to try to narrow down where that smoke was coming from, because smoke is a pretty good indicator of something wrong. And nothing too much was looking all that charred, so I needed to actually see where the smoke was coming from in order to find the source of it. But still, I didn't hit on these as the problem, as where the smoke was coming from. These were sitting right underneath a Molex type or something clip plug, and the smoke was coming out right next to it. So if the smoke was coming off of these, where it's discolored on the sides, it had to sort of go around that Molex to come up, and maybe that's why I couldn't tell exactly where the smoke was coming from, and that these were the likely problem, because I couldn't see the smoke emanating from these. They were under something. In addition to smoke coming from that point on the power amp board, after a little while, smoke also started coming from the protection circuit. Well, why? Okay, so these are half-ohm resistors, and they go on the emitters of two of the output transistors. And output transistors sink a lot of current, or push a lot of current, whatever. So once these failed effectively open, the easiest path to ground from there was through the protection circuit and through the resistors in the sort of comparator circuit on the protection board. And so that's why the protection board started smoking. After these had done smoking, those resistors started smoking, because now they were the path to ground. And so maybe if I were more clever, I could have figured that out more quickly. I mean, I figured some things out, but man, it took me a frustrating amount of time to figure it out. I did, because I'm not stubborn. I don't give up. Not usually. I might give up if I come across a problem that I know I can't fix. Because then why wouldn't I give up? I should give up if I know I can't fix it. And I'll put stuff on the back burner if I find it particularly frustrating, but pretty much I eventually get back to this thing and figure it out and fix it. Well, I hope that was interesting, maybe entertaining. Hope you enjoyed the video. If you did, please subscribe to the channel. Leave a comment. I suppose you could tell me what a bonehead I am, but I already feel like a bonehead, so maybe you could just friggin' back off, alright? I'll talk to y'all later. Have a good one.